Hi everyone. Today's topic is hypothesis testing. So what is hypothesis testing? It can be defined as a procedure to decide whether reject or fail to reject the null hypothesis, which is the statement of population mean mu. There are several steps in hypothesis testing for population mean. But before that, let's take a look at types of hypothesis. Hypothesis refers to a statement of the value of population mean, which is mu. Here, I prepare you a mind map of hypothesis. As you can see here, hypothesis can be divided into null hypothesis and alternative hypothesis. For the null hypothesis, it can be written as H null, and for the alternative hypothesis, it can be written as H1. For example, let's say that the weekly average expenditure of a student is 80 ringgit Malaysia. So it can be written as H now mu equal to 80 ringgit. Now, let's take a look at alternative hypothesis. For alternative hypothesis, we have one-tailed test and two-tailed test. For one-tailed test, it is also known as directional form, and for two-tailed test, it is also known as non-directional. For one-tailed test, it has left tail and it has right tail. For left tail, commonly we denote for left tail using less than symbol. For example, mu less than 80 ringgit. For right tail, we usually use greater than symbol. For example, mu greater than 80 ringgit. Meanwhile, for two-tailed test, we use unequal symbol. For example, mu unequal to 80 ringgit. For this one, you can refer to page 8 and page 9 on the slide on how to identify the correct symbol. Okay, this is on page 8 and this is page 9. Okay, first we take a look at page 8 first. Okay, so here we have greater than symbol, less than symbol, equal symbol, and unequal symbol. For equal symbol, we often write for the null hypothesis. Okay. Meanwhile, the other symbol is for alternative hypothesis. These are the keywords that is used on when you want to use greater than symbol, when you want to use the less than symbol or unequal symbol. For example, if it states that greater than, above, higher than, longer than, bigger than, increase. So these keywords shows that greater than symbol, similar to less than symbol, where you can find less than, below, lower than, shorter than, smaller than, or decrease or reduce. So all these keywords refer to less than symbol. For unequal symbol, you can see different form, has changed from, is not the same as, or it is not equal to. So all these keyword refers to unequal symbol. To enhance your understanding, let's go to page 9. So here, there are 3 examples. Number 1. Okay, so number 1, if you want to show the average number of kilometer per liter obtained from the certain carburetor is less than 20. So that's why here the null hypothesis is less than symbol. Number 2. Okay. The scenario is still similar. It's just that it used the different keywords here. If you can see here. So number 2 is more than. So that's why the alternative is greater than symbol. Use greater than symbol. And for example number 3 is different from. So that's why the alternative is equal. If you see here, all the null hypotheses use equal symbol for these 3 examples. It means that the symbol only change for the alternative hypothesis. The null hypothesis will be equal symbol and the value is similar. So this is how you want to identify or determine the correct symbol used for the alternative hypothesis. Next, let's see what it means by one-tail test and two-tail test visually. Let's start with left tail first. So this is the normal graph I have drawn here. This is the normal graph. Okay. Look at the left tail. So for the left tail, what it means by left tail? Yeah. So here, left tail means that it is on the left. So here, I'll draw you the rejection region and the acceptance region. As you can see here, this is on the left. So that's why I shade it on the left region. For the right tail, of course, it will be on the right. For the two-tail test, it will be both because left and also on the right. As you can see here, there are two regions, which are the shaded region and unshaded region, the plain one. For the shaded region, it is known as, this one is the rejection region. Here, rejection region. And the unshaded region or the plain region, this is the acceptance region. Same goes to for the right tail. Shaded is the rejection region. Unshaded, this is the acceptance region. So, for the two-tail test, you can see that there are two rejection regions on the left side and right side. The plain, which is the middle, this is the acceptance region. If you see here, this is, okay, this is point at which it separates the rejection region to acceptance region, which known as critical value. This is the critical value. Same goes to right tail. So this is the critical value. Or later it is known as CV. CV means that critical value. So for two tail test, it means that we have two CV here. I put it CV. You already know what is CV. CV stands for critical value. Okay, for left tail, left. Since it is on the left, so the critical value will be negative. For right tail, it is on the right, so the critical value will be positive value. Meanwhile, for the two-tail test, which we have two side, left side and right side, left tail and right tail, so the critical value will be negative and positive. So, how to find the critical value? Critical value is obtained from statistical table, either from Z table or T table, depending on population variance is known or unknown. For example, for this case, let's say that your alpha is 0.05. I start with the left tail first. Left tail. How to find? This is how we want to find the critical value, CV. As I mentioned earlier, if it is left tail, then the critical value will be negative value. Alpha is equal to 0.05. So you want to find the critical value. This one, let's take a look. Example, if you find the Z value, it can be Z or T. Depends on the population variance, whether it is known or unknown. If it is known, then we use Z. If it is unknown, then we use T. But for now, I will show you only for the Z. But you can repeat the same procedure for T value. Okay, for this one, it is on the left side, then the critical value will be negative number. So to find the critical value, negative Z alpha, so equal to negative Z 0.05. Then you look at your finding number in your statistical table. So it will be negative 1.96. So here the value is negative 1.96. Wait, I want to find the statistical table. Sorry, the value is 1.6449. So 1.6449. So here the value is negative 1.6449. Why it is negative? Because it is on the left tail. So the critical value need to be in negative. For right tail, we use similar alpha, which is 0.05. Since it is on the right tail, so Z alpha, Z 0.05 is equal to 1.6449. So here the value is 1.6449. It is on the right. So that's why the critical value is positive. For two-tailed, it means that you will have two critical value. One a negative value and another one is positive value. However, for this one, two-tailed test, you need to divide your alpha. Let's take the same alpha, which is 0.05. For two-tailed test, you need to divide it by 2. Alpha divided by 2 is 0.05. Sorry, 0.025. So you will have to value plus minus z 0.025 is equal to plus minus. You look at the number from the table 1.96. So 1.96. So here will be negative 1.96 and another one is 1.96. So how we want to decide whether to reject or not to reject the null hypothesis? Later, you will calculate the test statistic TS according to its cases, whether the population variance is known or unknown. For example, I start with the left tail first. Let's say that the test statistic, is equal to TS stand for test statistic is equal to negative 2. So negative 2 here will fall in the shaded region. Here is negative 2. This is example. I just take just any value. I just want to illustrate to you. We can see here that the value fall in the shaded region, which implies that shaded region is a rejection region. So it means that if the value fall in this region, your decision is reject null hypothesis. But if, let's say that you calculate and then you get your TS is equal to 2, positive 2. Positive 2 is here. So it fall under acceptance region. Then your decision is fail to reject the null hypothesis. Similar goes to the right tail. Let's say that your test statistic is equal to 1.7. So here 1.7, it could be here 1.7. So you see that the value fall in the shaded region, which means that rejection region. So if the value on the rejection region, you need to reject the null hypothesis. For the two-tailed test, okay, let's say that the TS test statistic, which you to be calculated later, is equal to 3.1, for example, positive 3.1. So here, it could be here, 3.1. So again, in the rejection region, means that reject null hypothesis. But if you get, let's say that the test statistic is equal to 1.5, 1.5 is here. So if it is 1.5, then your decision is fail to reject null hypothesis. So next is the steps in hypothesis testing. For hypothesis testing, I will show you two methods here, which are by using the traditional method, which is the test statistic method, and the p-value method. I'll start with the test statistic approach first, method 1. Okay, for method 1, we have 5 steps. It starts with hypothesis, test statistic, critical value, decision, and the last one is conclusion. So, first step is stating the hypothesis. For hypothesis, we have null hypothesis and alternative hypothesis. So you need to state your null hypothesis and alternative hypothesis like I mentioned previously. For the null hypothesis, it will be always equal symbol. For example, the previous example is I take when the mu is equal to 80 ringgit. For the alternative, the mu, it is depends on the question itself. What are the keywords that is used? Is it greater than? Is it less than? Or is it unequal? For example, let's say that the average weekly spending of student is, it is claimed that greater than 80 ringgit. So you use greater than symbol. If it is less than 80 ringgit, then you put it here, less than 80 ringgit. If it is different from 80 ringgit, then you will use unequal symbol. For this one, you can refer to page 8 and page number 9. Then we go to the next step, which is test statistic, or later I will denote this one as TS. TS for test statistic. For test statistic, this one, you need to calculate. Like I mentioned you, test statistic, you need to calculate. How to calculate? If you see here, go to your slide. Okay. So test statistic will have different formula depending on which cases. Is it population variance known or unknown? Because if it is known, you will use Z test statistic. If it is unknown, you will use T calculation. So what is the difference between the variance known or unknown? If it is known, we can use sigma here. If it is unknown, we cannot use sigma. But then instead of sigma, we use the sample standard deviation. Sigma here is a population standard deviation. As here, sample standard deviation. So for the test statistic, you will calculate either Z or T. So here we have formula like I shown you earlier. Depend on the case. Which case? Is it population variance is known or unknown? If it is known, then you take this formula and then you calculate. If it is unknown, then you use this formula and then you calculate for the test statistic. Then we go to critical value. Critical value, CV, the one that I showed you just now. CV is if the S is you need to calculate, then CV you take from the statistical table. For CV, okay, you need to know whether your hypothesis is one tail or two tail. One tail is either greater than symbol or less than symbol. If it is two tail, then unequal symbol. Remember, for critical value, if it is one tail is greater than or equal, then your CV is Z alpha or T alpha with degree of freedom lah. If it is two tail, this one is one tail. If it is two tail, which is unequal symbol, then your alpha need to be divided by 2. This one is for two tail. Then you may find the value in your statistical table. That is the number 3. Then we go to steps number 4, decision. Decision is how you want to reject your null hypothesis. So for this one, there are 3 rules. Okay, rules is how you want to decide. Rules. And these rules depending on your alternative hypothesis symbol. Let's say that if your alternative hypothesis is greater than symbol, this one decision you can refer to page 19 on slide. Okay, rules here. Okay, let's say that if your H1 alternative hypothesis use greater than symbol, then how we want to decide whether to reject or fail to reject the null hypothesis? For this method, you need to compare the test statistic value and critical value. If the alternative use greater than symbol, so TS greater than CV, then we reject the null hypothesis. This is the rules. Okay, if TS greater than CV, then we reject the null hypothesis. If the alternative hypothesis use less than symbol, then the rules will be if, here you should add if TS less than CV, then reject null hypothesis. If the null hypothesis use unequal symbol, then the rules will be if modulus TS is greater than CV, reject null hypothesis. So you have 3 different rules here depending on the symbol of the alternative hypothesis. You can refer to page 19 for further explanation. So this is page 19. How you want to make the decision. And then the last one, you can come up with the conclusion. The conclusion is actually from the decision. Let's say that if you reject the null hypothesis, let's say that your decision is reject null hypothesis, then your conclusion will be, for example, okay, this one I take example, okay, we're using this one. Null hypothesis is the mean equal to 80 ringgit, and then the alternative, the mean is not unequal to 80 ringgit. Just now, I said that if our decision is reject null hypothesis, reject means that we do not want our null hypothesis. It means that our conclusion is the mean is unequal to 80 ringgit. Okay, so here you can write it. This one is if you reject the null hypothesis. Then the conclusion will be, therefore, the average weekly expenditure is 80, is unequal or is different from, is unequal to 80 ringgit or is different from. It also can be written as different from 80 ringgit. Your conclusion is based on your decision, whether you reject or fail to reject. If you fail to reject, then your conclusion is the average weekly expenditure is equal to 80 ringgit. That is if your decision is failed to reject. Then we go to the second method, which is p-value. Here, I believe that you already know what is the p-value method because this method you already done for your Levene test. For p-value method, we have only 4 steps, which are hypothesis, p-value, decision, and conclusion. For hypothesis, similar to what you have stated for the test statistic approach, you just need to state your hypothesis, null hypothesis, and alternative. Similar, you need to state this one, similar. But it different on the second step, which is p-value. P-value, you do not have to calculate. So this value, you just take from the table. For example, let's see the slide. Okay, this one is on page 22. Okay, one sample means that a mean. Later, because we have a mean and two means. So where is the p-value? You look at this one, SIG for significant value. So this is actually your p-value. So the value here, 0.000. You cannot write as 0. No, this is wrong. You just copy exactly from the output 0.000. This is the value. And here, T stands for the test statistic. If it is given, then you can use this value. If it is not given and were asked to calculate, then you need to calculate the test statistic. T here stands for test statistic. And this one is p-value. Depends on the question. If the question asks you to answer it using p-value approach or using the test statistic approach. Okay. And then your p-value here, you need to see your alternative, whether alternative hypothesis, whether it is one tail or two tail. The p-value here, if your alternative hypothesis is one tail is either greater than or less than symbol. So this one, your p-value need to be divided by 2. Okay, for example, okay, let's take a look at example. Do we have any examples that is used? Okay, if you do not have an example, I'll just give you any value. So let's say that your p-value from the table, okay, from this table, let's say that here is not 0.00. Let's say that I write it as here could be 0.005. Okay, look at here. SIG two tail. It means that this value, this p-value for two tail test, for two tail. If you want it for your one tail, you need to be divided by 2. So, zero point 0.005 divided by 2. So this is your p-value for one tail, 0.0025. Is it? Yeah. In the table, the p-value for two tail. If you want for one tail, you need to be divided the value by 2, which later you will get 0.0025. This one I only do for example, 0.005. Okay? Because I know for this one, if you want to find the one tail, 0.000 divided by 2, then you will get the same. which is 0.000 also. Okay, if it is two-tailed, which is unequal symbol, then you do not have need to divide the value. You just take the value and just write your value here. You just divide it by 2 if and only if your alternative hypothesis is one tail. Only for one tail. This one is for one tail. And this one is for two tail. You don't have to divide it by 2. Just take the value and write it on your paper. For p-value, the decision, we have only one rule, which is if p-value less than alpha, then you will reject the null hypothesis. It is not similar to test accuracy approach whereby it has three different rules. Here. So the last one is conclusion. So conclusion, same goes to the previous one I mentioned. It depends on your decision. If it is reject null hypothesis, then your conclusion will be unequal or less than or greater than. Depends on your alternative hypothesis. Okay, so let's take a look at the first one. The first one, which is on page, here is on page 15. For this syllabus, you will have hypothesis testing for one population mean and for two population mean. Now is for one population mean. One meaning that you have only one group. This one only you have one group. Okay, for this one, you will have two different cases, which is known and unknown. This one is your variance, population variance. Your sigma is known. You know the value. This one is you do not know the population variance. You don't have the value. If you know the variance, the population variance, you will use Z. If you use Z, you will refer to Z table. If you use T, and then you will refer to T table. So this one, to enhance your understanding, by using this formula, you can do example number 1, number 3, number 4, and then example number 5. Please refer to the next video for explanation. Thank you.